I'm Ruxana Zia from CLT at Forman Christian College. You have already met Fatma. You've been meeting her since the past, I think, 11 webinars, and you will keep seeing her for the coming ones. And if you will not, you will listen to Zarek, who's the coordinator in the back, ground trying to handle chat and the Zoom accounts. The purpose of the series, as you well know by now, is to establish a collaborative community of scholars. It relies on peer sharing and learning. The free part of the online course is to provide a wider access to both national and international scholars to foster knowledge equity. And that is aptly demonstrated by all our experts who have generously given of their time and energy. Over the years, we have developed this course to synchronize with the Researcher Development Framework by WITE. And this framework was reconfigured in 2025, very recently. And so at present, the 24 webinar course we are offering you provides a strong coverage of some domains related to researcher values, behavior, research methods, digital literacy, ethical and responsible research, scholarly communication and publication, collaborative research culture, but it offers limited coverage of funding and finance, project management, supervision, and people management. And also partly a bit of coaching and mentoring is not covered here. Maybe also remind you that this course offers the FCCU values of service to community, and that's what's driving this course. The webinar 12 today is data visualization with R factor, and there are 8,300 registrations from 400 international and 230 international universities and from 93 countries of the world. The agenda, as you know, is about data visualization with R. And there are many other tools for data visualization, but we are covering this one. And this is a demonstration only session where you will be the researcher, Itrat Batool Naqi, who is an associate professor in the Department of Statistics here at Forman Christian College. She will sort of take you along with the whole process. And so it's nearly a 2 hour long, which will be very, very demanding, and you will have to be very patient and be careful as you learn along with her. She has over 20 years of teaching experience and 21 years of research publication, 21 research publication. Her research interests include statistical quality control, data analytics, and data visualization using R. She serves as the principal investigator of IRIF funded research project titled Tooth Eruption Time in Children of Lahore. And you will have to tell me, Itrat, what is IRIF? She's passionate about teaching, and she's proficient in statistical software, including SPSS, Minitab, and Mathematica. Welcome, Itrat, and over to you. It's always a delight to have you with us.
Okay, thank you very much, Dr. Ruxana. Can you people hear my voice clearly?
Yes,
okay.
Absolutely.
So thanks a lot for your humble introduction, and I'm obliged for that. And IRIF is the funding, it's the internal research funding by the institution, FCCU, and I'm the principal investigator in that. I won it in 2004, and it's now in the publication process. We calculate the primary data, and then now it's in the data has to be entered, and we play with the data, and now it's into the publication process. The data is so good. Okay. So we have to come to the point for the today's session. Assalamu alaikum and hello to all of my dear participants. And today, I believe that all of you have the basic essence, the basic knowledge of the R. at least the interface, at least how to call the libraries and the data sets, even though I will let you know about this from the scratch, that how you can call the data, the big data sets, and how you can play with that, especially in the context of the visualization. And also, there is a big demand for that, the basic statistics. Prior to that, we have done so many sessions with CLT prior, I think so, from last 10 years. Yeah, we were doing for the basic statistics tools like the simple bivariate, multivariate. So I will just test the test of association. We will test it over there for the basic testing tools. I will apply it for you, how to use the t-test, the p-test, and the z-test, blah, blah, blah. But after my main chore, which is the data visualization with R. So I'll firstly let you know about the data visualization. So these are my screen. I would like to share you. Just give me this second. Yes. Can you see the screen, my dear?
Yeah, it was absolutely.
Okay.
And you started in the name of God, the most
Allah.
gracious, the
Yes, the most
perfect.
beneficial. Bismillah ar-Rahman ar-Rahim. So, Assalamu alaikum and hello to everyone. Okay, you know very well about that this era, we are dealing with the big data set, which is called to be the, like, we have so many numbers, so many variables around us. Like we were talking about the primary data, so many information around us.
Can't hear you, Itrat. Are you there? You are muted. Itrat?
Ji, ma'am.
Ji,
Actually, it's
you.
for the slideshow board. They were saying to me, so we were doing. Okay. So
Okay.
you know very well that we have the huge information around us in the form of the numbers. And how to deal with the numbers, basically. When we have the less data set, priorly that 30 observation or 40, 50, 100 observation, we can count it, we can calculate the basic descriptive statistics, and we can do manually. But now this era is dealing with the thousands and thousands of observations with the so many multi-dimensional variables. So the question is that how to deal with data that a layman can easily know about the what, the patterns, the trends, the outliers, and the system related to the data set, who address the questions which you have like as a researcher. So that's why we choose this very fact that we are utilizing this data visualization, that even though the, you say, layman can be understand the things. Okay. So the data visualization is the method which taking the information and you can develop the charts, graphs, and the infographics in a nutshell, I would like to say. And it will give you the answer for the question, even you don't have it in your mind. For example, I seeing the scatter plot. ठीक है, scatter plot क्या होता है? I will let you know. The x and y axis पे हम कुछ plot करें. So scatter plot we are seeing over there, and you, as a layman, you can tell the trend. It is increasing or decreasing. It is having the upward trend or the downward trend. So the purpose is that even though if you are not much technical person, then even by the visualization, you can let us know about the patterns, the trends into the data set. So for the today's session, I have been choose the two data sets, which are basically the built-in data set. One is known as to be the Saratoga houses, which is containing the 1,228 observations with the 16 variables. And it's a big data set, it's considered to be, because manually it's quite difficult, even though the second data set, which is the academic salary data, which is the 397 observation on the 6 variable we have it. So it's seems to be a good enough data. These are the variables which containing over there into these two data set and the sources over there. Although these are the built-in meant for, we will just call it directly from the R repository. हम R से इसको call कर सकते हैं directly. You will see how we will do it. I will demonstrate it for you and would like to explain you from the scratch that how you can do that. At least for this session, I will let you know the things, very initial and basics things as well, that at least you have learned how to call such kind of files and do these practices for your own data set. So this, the two data set has been taken. One is containing the price, the lot size, age, land value, living area, the percentage of the college adults, and the fireplaces, bathrooms, rooms, eating, blah, 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 like that. So the multiple sorts of the question you have it, the qualitative and the quantitative merged over there. And similarly, the second data set is having the rank. It is about the professors, associate assistant, and likewise the lecturer, and the discipline. It's discipline like social sciences, pure sciences, like that, or ABC, categorical variable. And then the year since they have done their PhD, and years of service, they have it over there, the gender and salary. So there's a mixed mode data set, you have it. The first graph, which I would like to let you know by certainly demonstration, but priorly I would like to discuss the output over here. This you will see it over there. This can be done, its specific name, by grouping. Into the R we called it, we are grouping it out. But you can say, Itrat, it's nothing is drastically different over here. You are just taking the two variables like the salary and the year since they have done PhD, the two variables, quantitative variable, and you just make the scatter plot. And we are seeing that it's having the upward trend. That's it. So it's nothing be drastically important or significant over here. Everybody can do it. Just as that, it's a big data set. But no, my dear, if you would like to superimpose some more variables and the quality of the graph, the significance or the visualization will not be suffer, means like you would like to superimpose the gender, you would like to superimpose the rank, for example. So how you can do that? Like this. Look at there. Now, the question arises into one researcher mind that how many professor, assistant professor, and associate professor over there? So these are the ranks. It's basically an other variable which are imposing on that through our tool by the coloring legend. So हमने color करके we are imposing the rank variable. You see, prior to that, we were not able to see over there that how many professors, how many associate professor, how many full professor and assistant professor over there. But now we are seeing like this, okay? So it's red is known to be the assistant, green is known to be the associate, and in a one glance, anybody can let us know, even a child can let me know, okay, there are more professor over there. That's it. So big scene was there. One more thing. Now the cognitive thirst comes into my mind as a researcher. How many males and females over there into the each category? So now we are dealing with 4 variables simultaneously having the different nature. The 2 are having the quantitative nature and the 2 are having the qualitative nature or the categorical. So we are superimposing it, the 2 categorical variable with the help of the R through their color specification or through their style of the geometric points. How the geometric points we have to be developed over there. Like the triangle are representing the male and the circles are representing the females. So anybody can easily assess it over there that there are more and more professors and more male professors over there. The next is going to be the codes, basically what's run for that. We need to call these specific libraries into the R, my dear, which is known to be the ggplot, known to the grammar of graphic. It's a sub-library including to the tidyr. It's a big umbrella. Under the tidyr, we have to work for the ggplot, but ggplot itself work it for the social sciences. It is a very much big package library, you can say, which is helping out to see the visualization context. Then this syntax is calling the data for you. Data, this is the syntax to write to call the data from the built-in package in R. The package name is over there, car data, and you have to write it into the inverted commas, and then the specific file which containing the variables which I have been discussed with you, which is named to be the salary. So it's meant at least we have a file and we need to call it. And if we are utilizing the built-in data set, at least we have knowledge about the package in which that data set is residing, or the file has to be located. So to locate the respective file, we at least know the package and then the file name. Then we can view it. View meant for how many variables over there. It will let us know the detail. When I will run this code for you practically, then you will see it will let us know about the data set. The data set, the pop-up window will be comment on the screen and will let us know about the data, how many variables over there. Then the plotting sense. Now we are plotting it out. What we need to plot? We need to plot the salary file, which containing the respective variables, and along the axis for the x-axis and y-axis, we are just in the 2-dimension. So we would like to cover the year since they have done the PhD and the salary. Remember the priorly we have just plotted the two things. And geom points, you see the plus geom is the geometrical representation in which you would like to represent the data set. It's the points. You can represent your data set by the lines, by the bars, by the histogram, by so many things. But here we would like to display the just in the shape of points. So we are writing it over here, the points. Now labs is letting you know about the label, which is just for the aesthetic, which needs to improve the aesthetic of the visualization. It will just place the title on the top of your graph, academic salary by year since they have done the PhD. Now we are imposing the rank. As I have told you that by the simple scatter plot, it's nothing so meaningful. We are imposing the one categorical variable, and by adding it over there, we are adding the third variable by the color specification. You see, there is no mess, just the color will distinct with the different groups. So that's why it's called to be the group. And finally, we are adding the shape with the sex, that the gender, like the how many females associate assistant and full professor and how many males over there. So these are the all essence for that. This is the simple explanation for this. This is the library called over there. This is the data line called over there, and how we are working on that. And the ggplot is working for you for the axis. That's it. And geom points, I have already told. This code is for the dots. Points is meant for the dots. You are extended for the lines whenever you need it. You are extended for the bars whenever you need it. We can call it for the histogram whenever we need it for that. So in a nutshell, the code generates a scatter plot showing the relationship between the year since the professor earned their PhD, since year done PhD, and their salary. Each point represents one professor. That's it. And this is for this code explanation. But the important over here, you see, geom points, when we are adding the sex and the color, we are giving this additional information. Prior to that, we did not give. The size is representing the size of that point. It can be ranged from 1 to 5. 5 se increase karenge, then it will be more and more larger, which is not to be more suitable. So 2 or 3 is quite to be good. Alpha seems to be how much opaque or transparent the point has to be. So the range is going to be from 0 to 1, and the 0.5 or 0.6 is moderate range, or seeing to be opaque or the transparent. If it's going to be less than 0.5, it's going to be more and more transparent, and at 0 you cannot see the point, and at 1 it's quite solid point, you have it over there. So that's why it's moderate to be over there. The next is the just explanation for the same over there, which I have been discussed. You can get it over there. And access. So what the group has done for us in grouping, the value of the first two variables are mapped to the x and y axis. Then additional variables are mapped to other visual characteristics such as the color, shape, size, line type, and transparency. Grouping allows us to plot the data for multiple groups in a single graph. So it allows us to multiple variable in a single graph. Now, the second is going to be the correlation plot. Correlation is basically known to be the relationship between two variables. And it's what we are utilizing over there. We are talking about the Pearson product moment correlation, which is simply known as the R. And R is the quantitative variable. It's deal with the quantitative variables. Then the question must be arise in your mind, why not the qualitative variable? Certainly we can deal with the qualitative variable as well, but not by the Pearson product moment correlation. And certainly if we have, being a statistician, I would recommend that whenever you need to apply the things, kindly apply the things, the tools on the right data set. You cannot take the qualitative variable to check the relationship of the qualitative variable, categorical variable through the Pearson product moment correlation. Means simple R जो है correlation जो है, which is ranging from -1 to 1, it has to be quantitative variables over there. Means the height and weight of the students, means the salary and the year since they have done PhD, means both the quantitative variables you have to utilize. Now question is arise that why not, ma'am, the qualitative variable? Yes, we can check the association between the qualitative variables to qualitative, one qualitative and one quantitative, and all other streams by the chi-square test of association. So it's something else. Here we are utilizing the both quantitative variables. Usually we are dealing into the quantitative variables. And these sort of graphs you can get it after that. You see, what is the sophistication over there? You have it, for example, 1, 2, 3, 4, 5, 6, 7, 8, 9 of the variables, and with the 9 of 9, it's 81 correlation. On one click, you will get it. That's it. So between the 2 and 2 variables, you get it on one click, the relationship between the 2 variables. Priorly, it was just manually when we have to done the 2 variables, we take it at a time. For example, the lot size and the age. We can just talk about these 2 variables. But now with the sophisticated coding through R, we can get such sort of the, correlation plot in a one click. In here, we are utilizing the so many variables. And the legend over there, the color legend, it lets you know the intensity. The intensity is letting you know that it's the sharp red is going over there. It's like this, tend towards the red. So more and more positively correlated the variables. If the blue and blue area you are seeing over there like that, so the variables are negatively correlated. And if there is sort of the white sort of area you are utilizing over here and seeing over there, observing over here like this, so there is a weak correlation and the variables are seems to be independent in the sense. So hopefully you got it. And one more thing, my dear, this is the same thing and this is the splitting of the things. It's the lower half diagonal, it's the upper half diagonal. It's by your choice. You have to take the upper half or the lower half, but both are giving you the same information. Keep in mind, these are not the different, these are the same things, but just the presentation mode is different. If you would like to see the lower half, so you can present it like this. If you would like to see the upper half diagonal, you can like this. So the next is going to be the code, what it's letting you know about that. Again, I'm utilizing the same built-in data set, which is into the Mosaic data package. And the working library for that, I would like to say, for which we need to drop the correlation is the GG core plot. Why the GG core plot we are calling over there? Because we need the correlation plot. For the correlation plot, we need to call it library and deploy. But the deployer over there, deployer is the Again, package which is very sophisticated package. So many packages over there which can done the manipulation, data manipulation for you, the EDA, exploratory data analysis. So this is one of them. You will see how we can tackle it out. Again, the same thing, you are calling the data. The data name is the Saratoga houses. In the prior slide, I told you about that. I am utilizing the two data set. One is the Saratoga houses data set, and one is the other salute data, which we have just talked about that. So the Saratoga houses data set is from the Mosaic data. One more thing, my dear. This is the case sensitive language. If data ka D is capital, so you need to write the D capital. If you write it small d, it will not call it. It will create the error for you. So at least you have know the file name and how did you write it. How did you spell? So obviously spelling be clear hone chahiye, as well as the writing font, that it has to be the small cap or the all are in the cap lock, or like this. One is the cap and other are the small. Means to say it's a case sensitive language. So you need to be carefully do that. We are calling the data here, and then we are viewing it out, that the Saratoga houses data, how many variables over there. Then DF is just the, we are developing the formulating it out. Select if is the function from the deploy. You can say we are utilizing the deploy here, that select if is the function. In the function, you need to specify what you needed over there. You need the Saratoga houses से data चाहिए आपको, सारे variables कौन से, is dot numeric. As I told you that here, the correlation plot will just work it for the quantitative variable. See, so we are needing the numeric variable over here, not the categorical, not the gender like the male and female. It will work it for that. Not it will work it for the professor ranks A, B, C, D. So categorical and ranked variable like the qualitative variable, it will not work it over there. It will work it for the numeric variable directly just. And now here the function for the core kiska lena aapko, all the entire numeric variables ka. So use complete dot observation. It will remove the NS automatically and use it utilizing your complete observations over there from the DF. You see, I'm calling the DF here into the core. It's just the optional, just for the sophistication, because R will give you so many decimals over there, like 6, 7, 8, 9, 10 decimal points over there, which is seems to be useless. You can jot it down to the 2 or 3 or rounding it up for the 4 decimal place or 5 decimal place for the research purpose even. And now here is the plot. But then whatever you have calculated over there, you are calculating the correlations, the 81 correlations, the so many correlations over there. And then after that, you are calling it up. आप उसका एक diagonal plot develop कर रहे हो. Here, as I told you, it's up to you that you want the lower half or the upper half. That both will give you the same information. So here you are saying the hierarchical order. In order making true, it will accumulate the strong correlation, positive correlation in one side, the weak correlation in one side, the negative correlation in one side. It's make your graph more sophisticated or more aesthetic by these commands. Simply, you can get it by the core, ggplot core R. It will display for you. But these things will make your graph more sophisticated and more aesthetic things for that. So it's just an example. Another example for the built-in data set. You have it. You see, we have the strong correlation between the palette length and the palette width, which is certainly comply with the expectation. It has to be positively correlated. It's going to be near 1. Its association is high over here. And now the third is going to be multiple linear regression. But prior to that, I would like to, I think, share the working of these codes. whatever I have done. Then we will go for the multiple linear regression. Here. Okay. So as firstly, we have been discussed the grouping. So I would like to recommend the people who are working with me on R. So kindly, can you please open the R with you, the R Studio? The R Studio seems to be like this interface, which is the input window. That is the displaying your output window. Here is the environment in which you can see the variables. And the fourth is displaying the plots for you and the packages from here you can call it, and the other things which are more sophisticatedly you can do it. So firstly, I would like to run the codes for you as we were talking, the ggplot, grammar of graphic. I will run this code for you. If it's blue, then it seems perfectly working. There is no error. If it's going to be red color, then there is some error. And kindly get rid the warning. Warning aaya to just get rid about that. Do not worry about it. Just run the code again and be careful about the errors. So there is no error generated for that. And now the library, we are calling it here respective the car data. Why we are calling the car data? Because the salary is in the car data, and car data is the package in the R repository. We are calling it from the R repository. So the car data is calling over here, and now the sophisticated data, we are calling the salary from the car data package. Here we're calling it out, and it is already over there. Salary, you see, the comes over here, but we are not seeing the data. How you can see? With the view. V is capital. With the view, you can see your data set, and it's a pop-up window for you displaying the data set, which is let you know about the variables. The rank is over there, the discipline is over there, the year since they have done PhDs, your service, the sex, the salary. So we are the merger of the quantitative and the qualitative variable into this data set. And now we go back to the code window that it's going to be run the whatever we have learned. See it over there. This is same histogram, a big it's the plot which for the X and Y, not the histogram, sorry. So this is just the plot, plotting the scatter plot. It's nothing drastically different. Everybody can do. But the next thing is going to be colored it by the rank. Now here you are utilizing the grouping. See it over there? Yes, it's there. The assistant, associate, full professor. Now, the third is going to be, as I have already explained the codes for you. So I jumping over the things. Now it's over there. The third thing is sex, the gender. How many males and the females. It's the similar thing which I have told you. Okay, so I would like to zoom it out and switch to the second window here. It's like this. Here is the same output which I have been shown you into my slide. And by running the code, it's displaying the same information. So what was in the nutshell we can say? We can say more professor, male professor, and in this data set. How you said you will be satisfied with my words. इसके लिए हमें कोई numerical justification चाहिए. We need one numerical justification that how do I believe? Okay, we can check it out by the table command that how many ranks with the sex. See it over there. The contingency table is providing with the ranks, assistant, associate, and full professor, and their gender, their sex, male and female. This is the contingency table, categorical variables over there with respect to their respective numbers, the counts. How many counts for the male and full professor? 248. So it's meant for that the 248 is the maximum among them. So it's complying with our expectation. So many other things you can do it for that to checking it out. But this is the simplest way to make the contingency table for that, or the call it by the table. The next we have done was the correlation. So the correlation I has been utilized the what? Mosaic data. Mosaic data, I would like to call it over there. Okay, this is just the warning. It's giving me the warning that this is the built-in answer 4.2.3 because my version is 4.2.1. So it's just giving me the caution that you need to update your R version. But I would like to get rid. Abhi main isko, I don't need to be update. So I will run this command again. So it's going to be blue. So it's meant no worry about it. Now you have to call it again. It's giving the warning again that it's built in. So I will run it again until and unless there is a error command. Error na ho, error ko resolve karna apne, warning ko you can get rid. Just see the warning, what it's giving to you. That's it. And the deployer again. So for the all libraries, it's giving me the caution that I need to be update my version. Now I am calling the three libraries over there, the Mosaic data, then the ggplot core and the deployer. And now again, I'm calling the Saratoga houses data set over here. It's data, calling it out. And you see the environment is letting us know about the variables. That salary data is over here. Now the Saratoga houses data is over here. I would like to see this data set. And its pop-up window is letting us know about the all information for the data sets. It's 16 variable over here and 1,728 observations. You see, like that. So this seems to be a big data set. You have it. Now go back again. What we need to utilize over there, we have to do the, what we need to do, correlation. So the correlation is calculating into this R. R is calculating the core for you. I will run it for you. And you see, there is no display. Why not? Because I'm just storing it. My core is stored into the R. I would like to see the output. See it into the output window. I can make the big for you. Close this. You see the price with the price certainly 100%. Its diagonal is always the 100%. Why? Because it's with the same variable. And the off diagonals are real values for your correlation plot. The first is the lot size and the price. It's going to be the 0.158. It's 0.16 basically. So many decimal points you are seeing over there, positive and negative values. For the sophistication purpose, I would like to round it for the 2 decimal places. So the round R by 2. It's like this. See? Now it's going to be like this. And in this command, it will be generating the correlation plot for me. Okay, this is the correlation plot. By even though if I have no idea about the particular value, then even I can let you know that these red colors, the more tend towards the reddish, is positively correlated, and the more tend towards the blue is going to be the negatively correlated, and the white seems to be independent variables. There is no association between the 2 variables, like the bedrooms and the age. No association. How many bedrooms into the one apartment, and the age is having no impact for that. Like this, 1, 2, 3, 4, and like the 4. That's it. So now here, being a statistician, I would like to see the numerical observation as well. So I would like to display the numerical observation, and I would like to zoom it out and see it clearly like this. I would like to show here. Now my estimation that it's going to be the negatively correlated, how much? How much the strength of association of the negative correlation between that? This particular value is letting us know more and more tend towards the -1. It's more and more rigidly, strongly negatively correlated. Kindly, there is a misconception about the sign. It's a unit-free measure. So keep it in mind that negative sign is not letting you know the weak correlation. Please keep it in mind. The negative is just letting you know the opposite direction of the two variables. That's it. So these are approximately 0.4. If you have it the 0.5 or 0.4, it's moderately correlated, negatively moderately correlated variables. And like this, if you have it 0.73 or 0.72, it's 0.5 say zyada value, it's more than 0.5, positive 0.5 say, so it seems to be strongly positively correlated and tend towards 1, highly strongly, yeah, highly correlated. That's it. So please do not be misconceived with the negative sign, because it's a unit-free number, it's a pure number, it's letting you know the strength of the association between the two variables. Now go back to the working window in the R Studio, and likewise you can do that. That's it. Hopefully these two concepts are clear in your mind, and these are very much utilized by the social sciences people and the people who are working in the research, that the correlation plots it so much matter over there, and you can merge it for the quantitative and qualitative variable through the groups and the facet as well. So many other sophistications over there. There should be one workshop, I believe, for a week at least, so I can let you know more and more sophisticated methods like the heat map, like the tree map, like the mosaic plot, like so many other things on that variables. But due to the time constraint, I would like to go on the other things. Okay, so here we are talking about the correlation plot. So till that we have been discussing to this slide, and I'm going back to my slide, and we will discuss about the correlation. Here we are utilizing the multiple linear regression, or we can talk about the simple linear regression as well. So what is meant for the linear regression? Linearity is basically when we talk about the simple linear regression models, and one variable is depending on the other. Like we have been discussed prior to that, the correlation. In the correlation, we have no idea that which variable is depending on the other. Means both can be dependent variable, like the height and weight are both depending on the age. So we can calculate the correlation between the height and weight of the students. But the modeling is more sophisticated. Whenever you have a clear-cut idea that one variable is dependent and the other is independent, or independence, like the marks of the students are depending on the how much time a student spend on the study. So you have a clear idea about the marks relation with respect to the time spent to the study. One is the independent variable and one is the dependent variable. So obviously you can check its correlation, and in my view it has to be the strong positive correlation between the marks and the time spent to the study. But if you model it, so modeling will you give you the forecasting, the estimation, and much more sophistication. So this is the multivariate analysis. Now we are talking about the multivariate analysis in that. Prior to that, we were discussing the bivariate relationship between two variables. At a time, thousands variables you can discuss, but two variables at a time you can discuss on the correlation plot. But in the multivariate analysis, you can discuss the 3, 4, 5, 6 variable at a time. Here we are letting you know that, for example, we are discussing the marks of the students are based on how much time spent to the. So this is the simple linear regression model, because response variable is the marks, which is depending on just one variable, which is the time spent. If you have more and more variable, like what is the student-teacher interaction, what is the time travel to the how much absentees the student took into this course, what is the course content, what is the IQ level of the student. So many different independent variables you can add it in that. Whenever you have the so many independent variable and one dependent variable, and as well as the one more core restriction on the dependent variable is the quantitative continuous. Whenever you have a quantitative continuous variable like the marks can take any value. Out of 100, a student can take 99.99 or 19.95 or 80 or 70 or 75.75. So it can take each and every value within the given interval. So it's a quantitative continuous variable. So for the quantitative continuous variable, heights, weights, marks, temperature, length, width, you can develop the linear regression. So there is no restriction on the independent variables. It can be qualitative, it can be quantitative, it can be discrete, it can be categorical, ranked, or whatever so. But there is a restriction on the response variable, which has to be quantitative continuous. So here you are utilizing the modeling. For the modeling aspect, this is a very rich background. I believe if you have at least a knowledge about the linear regression, so you are good enough into the statistics. So statistics knowledge is demanding over here. So you are putting the linear model. This is the function. Into the small parentheses, you would like to write the syntax for that. The first variable you are writing over here, this is the price. So the price is the quantitative continuous, and price is depending. The tilde sign is known as belongs to. Price belongs to, price depend on the other variables, which are variable lot size, age, land value, living area, bedroom, bathroom, waterfront, and so many other quantitative variables you can add it over there. But I am just utilizing these 5-7 variables from dataset कौन सा आपका Saratoga houses. So this is the syntax from linear model till this parenthesis. You need to specify to call to apply your linear model. But in this webinar, I will not talk about the significance values for the linear models. Otherwise, you will be confused. I will just let you know about the visualization aspect. Anybody have an idea about that whenever we need to apply the linear models, we have some assumptions. The assumptions we would like to check it out into the just need to show it over here. It's like this. Yes. So we need to check the basically assumptions into the visualization context. The same code I'm copying over here for your concern that the data is Saratoga houses packaged from Mosaic. So I'm calling it again. Here I'm applying the linear model, and as I told you, I'm not going into the numerical aspects or the pure statistics. I will just let you know about the plotting. Even though you see in the output window, you are having the all output related to the multiple linear regression model. And by the way, it's called the multiple linear regression model because price is depending on more than one independent variable. 1, 2, 3, 4, 5, 6, 7, and blah, blah, blah. So if you are just taking the relationship between the price and the lot size, this is called to be the simple linear regression model. If you are taking more and more independent variables, so it's called to be the multiple linear regression. And here we took the summary, which is over here. But as I told you, I'm going to the plotting aspect of that. So it's over there. And here I need to hit the window and it will plot it for me. You see in this window, the residual versus fitted. Residual क्या होता है? Residual is going to be the error. ठीक है, क्या रह गया पीछे? What is the basically residual is knowing you about the difference between the observed and expected value. Expected is the fitted value. the contracted difference, observer expected ka contracted, the lesser difference is giving you the best model. That's it. Y minus y hat contracted or tend towards the zero, it's known to be the good fitted model. This is known to be the residual. This is known to be the error. So there shouldn't be the relationship between the residual and the fitted values. कोई रिलेशन नहीं होना चाहिए. How we can assess through the graphical representation. You see, this is approximately 0 over here, this line, because it's a negative sign over here, it's a positive sign over here, and its y-axis is measuring automatically residuals for you. So residual seems to be 0. Y seems to be 0. You see this dotted line. Okay, I can zoom it out for you and share it, the zoom version with you. Then it will be clear for you, my dear. Here, you see the dotted line. This dotted line is the rule of thumb. Rule of thumb is meant for, it's for 0. And this red line, which is quite along to the dotted line, this is for your fitted model. If it's along to be the dotted line, your fitted model, residual versus fitted, is going to be along to this rule of thumb line, then it seems to be a good fitted model. The second thing which you need to be observed into the graph of residual versus fitted, that the points has to be evenly distributed, which is approximately over here. I'm saying not 100%, but approximately even distribution of the points. Even matlab half upper, half niche. The even distribution of the points is known as linearity. Numerically तो हम justify करते हैं that y hat is equals to alpha hat plus beta hat x. X is having the power 1, y is having the power 1, so it's known to be the linear regression. Even though in the multiple sense we have it, the x1, x2, x3, x4 having one power or exponent means to be the linearity. But in the context of the visualization, what is meant for linearity? Linearity meant for, which is the core assumption to apply the simple or multiple linear regression, is that the points are evenly distributed along this dotted, or rather this red line, because this is your data line and this dotted line is the rule of thumb. And the most importantly, this red line has to be nears or superimposed and just complying with this dotted line. So then you can say that the both are fulfilling over here. What fulfilling? The linearity condition is fulfilling over here. The points are evenly distributed around the line, and the red line, the fitted observations are, the fitted model is almost having the 0 residual. So this is the first core assumption for the simple and multiple linear regression in the visualization context, the linearity. With the even distribution of the point, you can go for the linearity. Now we will discuss the second point. Okay. Here, the QQ plot. Again, I would like to zoom it out for you people that you can see it into the clear way. Yes, what it's letting you know. The second 4 more important, or I would like to recommend, this is the first 4 more important condition to apply the simple or multiple linear regression model. That the response variable, what was the response variable here? Price. The response variable should be normally distributed. Quantitative continuous should be meant for normal distribution, usually in statistics context. When you have the bell-shaped curve, so the points are evenly distributed around the center, mean, and they equally spread with a plus minus of 3 sigma limit. Simple words may, data response variable should be normally distributed. How we can see and assess this aspect into the visual context? We can assess this visual context into the QQ plot. You see this dotted line? This dotted line is representing the theoretical quantile. It's basically for the normal probability plot. And this line, because it's a big data set, you have the 1,728 observations. So these are the 1,728 observations. The fitted model, the response variable is quite along with the dotted line. So yes, there is not 100% accuracy over there. The edges is going to be diverting, but at least from here to here, I can say the 90% data is along the dotted line. So it's meant for approximately normally distributed. That's it. The next is going to be, I would like to share the third point, which is the scale versus location. So the scale versus location is showing the homoscedasticity, equal variability. Homoscedasticity is going to be the third foremost assumption, which you can see it over here, a bit of the diverting. You see, the red line, again, the fitted regression line, even the points are evenly distributed, but it's not along the x-axis. It has to be along the x-axis. What does it mean? It's mean few of the variable in your model are having more variability as compared to the other, or less variability as compared to the other variables. So that's why this red line is diverting. So as approximations over there, so we can increase the data set, we can increase the relevant variable in order to minimize these sort of the things. And the fourth is going to be the Cook distance. It's again for the residual versus leverage, but it's more and more can be justified through the numerical observation. There's a Cook distance we have to be discussed over there. But here you can see this has to be along the dotted line, and the red line is over there, fitted observation. And the area, this going to be like this dotted line and this. If your entire data set is covering over here, which is over here, so the Cook distance said there is no inferential point. This is just the visualization aspect for the Cook distance. Numerically, you can see it by the 4 by n. N is going to be the total number of observation into the data set you are utilizing. So if it's going to be larger than 0.5, 4 by n is going to be larger than 0.5, then that point is known to be the inferential point. In the numerical aspect, you can go for that. But in the visualization aspect, you can go it like this. This area, which is the dotted area over here, if your data set is, which is approximately over here, seems to be not having much inferential or disturbing outliers into the data sets. So these are the important visualization aspect. Now, one more thing, sometimes you can say that if we have our own file, like I am working on a thesis and I have generated my own data file. Usually we are working for the CSV files, which is the comma separated files. It is utilizing or call it by, or the Excel file, usually we have it. So we can call it through the respective libraries. For the Excel file, I am giving you the example over here. For the CSV file, you can go for the read R and you can call it by that. So the library, because I am having the Excel file over here, which is the lung capacity data, and I would like to utilize it for the simple linear regression. Why I'm doing this for you? Because we have already done the more sophisticated way, the multiple linear regression, and I'm going for the simple linear now, because you need to call your respective variables through your own data file. Because till that we were utilizing the what? Built-in data sets, built-in packages from the R. Now somebody can ask to me that if we have our own data file, how we can utilize it? Usually we have the Excel files. So I'm taking the example for the Excel. Or CSV files. So CSV can be from the read R. Kindly keep it into the mind. So the library is going to be the read Excel. Firstly, we need to call it and giving me the warning. So it's get rid the warning. And now I'm calling it up. So where is my data? just call the data, or I can view, as I can told you. So it's over there. This is my data set. And I'm fitting the linear model. Now, this is not the multiple linear model. This is the simple linear regression model for that. And how I'm calling it out, and why am I calling the simple linear? Because you see, lung capacity is depending on the age. I can utilize the gender, I can utilize the smoking, I can utilize the height and the other variables as well. So we are calling it out, I'm fitting it out, and it's over there, it's fitted over there. I can check the correlation, simple correlation between these two variables, which is the age and the lung capacity, and it seems to be 0.82 approximately, which is the positively highly correlated, means to be with the increase into the age, because age is going to be the independent variable, the dependent variable has to be increased, the lung capacity has to be increased, and certainly it will. Now, for the plotting, I would like to write this over this. So the age increase hui and the lung capacity is increased. There is an increasing trend over there. And now I can fit the trend line in that. You see this trend line is covering. Yes, the points are evenly distributed along the trend line. So there's certainly a best fitted line over here. And now I'm taking it out for the 4 plots, which I have been already discussed with you. It's like residual versus fitted, which will be checked the what? Linearity. It's checking the linearity between now the simple linear regression model for the age and the residual. Now the second graph is checking the normality. Oops, it's quite pretty good graph over here. You have it for the normal response variable is following the normal distribution. What is the response variable over here? Is the lung capacity. Whatever you have writing on the left side of the tailed is going to be the response variable. And why I'm writing this D1 and dollar? D1 and dollar is, D1 is basically the file in the, here I'm storing, this is the variable name in which I am storing the file. So my entire data set is over here in D1. And dollar is just the syntax to call a particular variable from that respective file, because there are so many other variables, we can view it out. So the lung capacity is the response variable. It has to be on the left side of the tail. And on the right side of the tail, you have it the what? Independent variable. And to calling it out from your respective, these things we haven't done into the prior codes. You see, when we have done like this, we just call it like the lot size, blah, 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 blah. Yes, but the one more sophisticated things we have done it over there, we call the entire data and let it know to the R that I am calling the all variables from here. But this will not work it for the your data file. It is just for the built-in libraries. It is just for the R packages data files. So for your own files, you can utilize it, the file in which you are storing it out, the storing operator, the variable in which you have stored that file, and the dollar sign is the syntax. If you will not apply the dollar, it will create the problem for you. Now the second point was the lung capacity is the response variable, and it's going to be pretty normally distributed. Yes. The third thing was homoscedasticity. Homoscedasticity was the equal variability. Equal variability is, like I told you into the last graph, that it has to be along the, no, I can show you the zoom that it will be more clear for you. Share it, the independent graph. Look at there. It is into the almost center along the x-axis. The first and foremost condition is for the along the x-axis. That's it. And the points are evenly distributed around the line, the fitted regression line. One more question. Why we are utilizing the standardized residual? I'm giving this question for the people who are having some prior knowledge of the statistics, so it's beneficial for them as well. I know few of the people were much confused for that. that what is the residual, what is the standardized residual, but I'm giving this information for those people who are having some knowledge, because majority, I think so, I believe, having some prior basic knowledge of the statistics. So standardized residual we are utilizing here, not the simple residual, because we are having, if we are applying the मल्टीपल लीनियर रिग्रेशन, अगर हम मल्टीपल लीनियर रिग्रेशन अप्लाई करते हैं, सो सिंपल में भी केस है और मल्टीपल में भी, सो व्हाट वी हैव टू डू, so many variables, so many independent variables you have it, like we have it so many variables like the age, land value, living area. So age having the different units, land value having the different units, age in the years, land value in the rupees, living area into the square meter. So every variable is having their different units. By standardizing it, standardization is make it unit free. So this is meaningful to test it out by their standardized residual rather than their actual. Because by standardizing, we are taking the unit free variables. So it is more meaningful. I hope you understand this thing. And the next is going to be the leverage over there. Here again, the cook distance is like within the range, and it's like this. You are utilizing it, all the data set in the range. This dotted line, which is making the L shape over here, this is our cook distance. And if the entire data set is lying into the cook distance, that there is no inferential point. And numerically, as I told you, that it can be utilized by the 4 divided by n. N is the total number of observations. So we have plotted it out, and one more sophisticated way you can see it. So one more thing you can see it out here, that the 4 sophisticated graph on the one screen. How you can utilize it on the one screen, I can let you know. Firstly, we need to be clear it out. Let me share the 4. Look at that. So at a time, you can utilize the 4 graph at the one screen with the simple par m for par 2 by 2 command. Okay? So it's a 2 by 2 for 2 rows and 2 columns. So you can see the 4 diagnostic plots on the one screen. Okay, somebody can say to me, if let's say I will write it the like this. For example, if I will write it 2 by 3, what will happen? 2 rows and 3 columns. So is it the meaningful over there? I don't think so. Let it see क्या होता है आपके साथ. So we can see it out. Like this. These are the 2 rows and 3 columns. So it's not to be more sophisticated. The statistics has to be decreased even. So anyhow, if you have more and more graph, so you can just utilize this par m from rows 2 to 3, 2 to 4, 4 by 4, 6 by 6, any number you can give and utilize your graph at a time on one screen. So this is for the simple and diagnostic tools we have been visualized for the simple and multiple linear regression models, and the bit of the correlation plots we have been discussed, and the bit of the grouping we have been discussed, utilizing into the more qualitative and the quantitative variables superimposing on them. And now I'm going for the testing, because I know the testing is more and more demanded usually by the social sciences people. And in the testing, we are not having such, you can say, visualization aspect, the numerical aspect we have been discussed. So here deliberately I have chosen the small data set. How you can write? You can write like, for example, you have the male and female data set into the class, and you would like to test their marks. Testing of hypothesis for the t-test. So what is meant by the hypothesis testing? A very quick view, I will give it to you. So what is the hypothesis testing? A hypothesis is basically a statement. Actually, why I'm doing this for you, because it's the statistical tools and the visualization. The visualization aspect has been much and much covered from my side, and you can ask the question related to that. And as I know, the more and more things over here, my dear, but with the time constraints, and we can discuss these things. And I think this is the more important things, that the people have an idea about the testing as well, because it's a major part in the research and the behavioral analysis as well. So that's why I'm discussing for the statistical tool as a hypothesis testing over here. A hypothesis is like a statement. It can be the assumption, it can be the postulate, it can be a statement which a researcher made for his or her research. For example, we are all, majority of us are the teachers. We came to know that we come to the class and we said, I believe that on the average, I said, the height of the class is 5.5, 5 feet, 5 inches. This is my belief. This is my postulate. This is my assumption. This is my statement. I need to test it out. Got it? I need to test this assumption. And similarly, it can be go for both. If I am having the male and female into the class, so I can say the male on the average having the higher height as compared to the female, or both are having the same, or one is having the lesser, likewise. So this is all about my thinking. I need to justify it with some numerical observation, with some numerical entity. So that is known to be the hypothesis testing. And keep in mind, always, hypothesis is basically go for the parameter test. Parameter को हम mu को test करते हैं and काम करते हैं on the basis of entire sample. We took a sample from a population and set our hypothesis for the population and discussed it in the context of this sample, the calculation based on this sample, and draw the inference about entire population on the basis of that sample. So this has come into the stream of inferential statistic. This is the inferential statistics, and it's a bilateral relationship, you can say, when we are talking about the two populations as well. So the parameter R into the population, you can say mu, the difference between the means, the proportion, the difference between the proportion, the variance ratio, and much more. These are the things which are usually utilized into the research. You would like to test the difference between the two population mean. You can test the proportion, difference between the proportion. You want to test the variances of the two populations, usually. How to make it? These are the 7 steps, which quickly I have to go it for that. Like the step 1, you need to formulate it. You need to formulate your hypothesis. As I stated to you, that this is my belief on the average. Mu is the mean of the population. On the average, the height, some specific value of that parameter I'm giving over there, which is known to be the mu naught. That on the average, the height is going to be the 5.5. That's it. So being a critical researcher, H1 certainly denied that no, it's not equal to that. Null hypothesis saying always there is equality, no difference. Whatever you are thinking, it's correct, mu is equals to 5.5. But as a critic, as a true researcher, I would like to test it simultaneously. Certainly, these two hypotheses has to be formulated, the full research. And I would like to say, no, it's not. It's not equals to 5.5. It's something else. What it has to be? It can less, it can greater. But if it's less, so I need to suppose like this into the null hypothesis. If the null alternative hypothesis is going to be lesser, then the null hypothesis has to rigidly greater than equals to. But the equal stance is over here. You see, nullify. It's nullifying the entire thing. So there is no difference. Greater or equal, lesser or equal. But this is quite rigid. No, it's rigid. It's rigidly we are saying we are if we are accepting it out, So we are saying it's lesser than that. It's greater than that. It's not 5.5. Let's say we are just talking about, these are three different stages. We can go step by step. First of all, we need to test it out. It's equal or it's not equal. So when we are, let's say we are accepting the alternative hypothesis that it's not equal. Again, we are in ambiguity. If we are supposing that mu is equals to 5.5, and here we are accepting the alternative hypothesis that mu is not equals to 5.5, then what is this? We are in the two blinds. It is greater than 5.5 or it's less than 5.5. So it's not to be as a good alternative hypothesis. It's the two-sided hypothesis. Keep in mind, this is called the two-sided hypothesis, lying on the boat tail. It can be the greater value of that, it can be the lesser value of that. So what is the true researcher hypothesis or the critic is that? Yes, it is lesser than that. If we are accepting it out, H1, so we are rigidly saying the height of the student on the average is less than 5.5. If it's 5.4 even, but it's less, we are confident. It's not to be the higher than that. And here we are confident that it's higher than that. Even it's a 5.51, but it's for sure higher. So these are the one tail hypothesis and having the more significance into the research. So do not rely on just the equality and not equality. It's just the testing is the first step, you can say. I will show you how you can go move further for that. Now, the alpha, you need to decide about that. You have an idea. I'm pretty good sure about it. You have an idea about that, my dear. Then these are the tests which are primarily working for that. When we do the manually these things, it was quite hectic for us. And thanks to the more sophistication, thanks to God, Allah Almighty, that we are having the much and much software which are more sophisticated and automatically do so many things for us for one click. So we can utilize the Z, T, and so many other tests for that. Why? Basically, these two mainly we have to test it out. What is the main difference in that? When you have the large sample is based on greater than equals to 30. Because when we have to do manually things, those statisticians decide 30 say bada, larger than 30 is considered to be a large sample. So whenever you have a large sample, so you have to go for Z test. Whenever you have a small sample, less than 30 observation, so go for T test. And by the way, when you have the large sample, so the Z and T will give you same result. So that's why, and the built-in function for the SPSS, for the Minitab, for the R, it's usually they're utilizing the T. Although you can use the Z as well, but T is more conservative in sense of when you have the small sample. So you go for T test when you have the small sample. Small sample considered to be the less than 30. Okay. Or if you have the large sample greater than 30, so do not go for, basically both will give you the same result. So Z is more sophisticated to large sample, but T is utilizing for the small sample. And here, the same thing, I'm letting you know about it and letting you know about the variability. Now, priorly we have the tables. We have to look at the table value, critical value to accept or reject the hypothesis. But into the advancement into the tools, the built-in function automatically into the R, SPSS, Python, Minitab, and so many other sophisticated Mathematica, you can utilize the p-value. The p-value is the probability already calculated with respect to your alpha. If the p-value, which is the probability of error basically knows to be, is less than alpha, alpha needs to be decided priorly into the research by yourself, which is the type 1 error, accepting H0 when H0 is not true. So this is known to be the alpha or type 1 error. And if the p-value is going to be lesser than alpha, then what should be the result? We will accept the alternative hypothesis, H1 or HA. If the p-value is greater than alpha, 0.05 से बड़ी हो, then we need to accept H not. If the p value is less than alpha, 0.05 से less ho, so we need to accept our HA, alternative hypothesis, or H1. So we need to, these are the tabulated formulation which are updated now. I don't think so people have utilized it, but these are the set values over there. These are the practice question. So we will go for the practice question now, on the R. Here I have took the two variables like the male and the female, and I would like to test. For example, in my class I said this is the marks of the students, this is the marks of the male students, this is the marks of the female students. So I would like to test it out, and in one class look at there, what is that? Variance dot test. As I told you that you need to utilize t-test, and we are using here t-test, you see, for the small sample. Small sample was less than 30. For the male and female, priorly for applying the t-test, you have to utilize the variance dot test. Why so? Because there is the first four more assumption that to apply the t-test, the data come from the normal distribution, normality. So normality को कैसे टेस्ट किया जाता है यूजुअली, और एटलीस्ट हैविंग द सेम वेरिएबिलिटी, नॉर्मेलिटी ना कहें, वेरिएबिलिटी सेम कह लें, हैविंग नॉट ड्रास्टिकली डिफरेंट, they are independent. Zaira, male and female marks are independently distributed to them according to their time, for example, time spent to study, according to their hard work, according to their knowledge, according to whatever say. So they are independent basically, but from same population, from not two different population, we are utilizing it up like that. They are independent sample t-test we are applying over here, but the variability, the other parameters are same. So we need to be tested out variance dot test priorly. What is the criteria? As I told you, in the null hypothesis it's written that the variance of male is equals to variance of female. And here our target is to see that the variance of male has to be equals to variance of female. होना चाहिए, तभी हमारी assumption fulfill होगी. And if the p value is larger than 0.05, which is quite larger, अगर 0.05 से बड़ी हो, ये क्या है 0.8 है, 0.05 से बहुत बड़ी है, तो इसका क्या मतलब है? What does it mean? It's mean we are accepting our null hypothesis. What the null hypothesis stated over here? Null hypothesis stated over here that the variance of the male is equals to variance of the female. So here हमें null hypothesis accept करना ही करना है to apply the t-test. Let's say अगर if the null hypothesis is not accepted and the p value is going to be 0.01, let's say, what will happen? So you do not apply the t-test. फिर आप t-test apply नहीं कर सकते. Firstly, you need some other things like the transformations and like the other things. Go for the population. Is it from the same population you have taken the sample, even though they are independent sample, but the other parameters are going to be same. For example, what are the parameters? Class 1, semester 1 grade ke students and semester 8 grade ke students. They are having the different parameters, age factor, IQ level, knowledge. So they are not to be the same population considered to be. Now variability certainly vary. So in that sense, we need to be do that. Anyhow, so variant test is going to be approved over here. So then we can apply the t-test. When you are applying the t-test over here, see, okay, the p value is going to be what? 0.54. Again, you are accepting your H naught. What does it mean? On the average, the male is equals to the female in context of marks hai, whatever you are utilizing here. On the average, the marks of the male is going to be equals to the female marks. So if H naught is accepted, do not need to check the further. H naught accept ho gaya, do not go for the nullify ho raha. There is no difference between the marks of the students. Both are having the equal stance. But let's say we have data set like this: male, female, variance test firstly. Okay, variance test is going to be fine. And now we are applying the t-test for that. Look at there. It's 5.85 e raised to the power minus 10. What does it mean? It's meant very, very low p-value. 0.9 times 0, then 585, which is going to be 0.000000585, which is a quite low value over here. So what does it mean? We have to accept the alternative hypothesis. What the alternative hypothesis letting you know over here? If mu is equal stance, then the alternative will let you know automatically not equals to. Not equals to, then the marks of the male is not equals to the female marks. Okay, so what does it? Is it greater? We are again in the blind stance. We have no clear vision for that. If it's equal, if it's not equal, then it is lesser than that or it is greater than that. So we need to define the alternate. Alternate first let us know less. Less meant for the male marks is less than female marks. Let us test it out for that. Yes, the p value is going to be the, again, very low. Minus 10 is raised to the power meant for 0.0090 zeros and then this value, 2925. So it's meant, yes, the male marks are rigidly lesser than female marks. You can see it over here. That's it. And let us try for the greater. Greater का आंसर क्या आना चाहिए? It shouldn't be. अगर ये less आया है तो उसको क्या आना चाहिए? Let it see. Okay, the p value is going to be 1. Yes, it's complying that in the alternative, if you'll put it that the male marks is greater than the female marks, no, it's not. So you have to be accept your or null hypothesis in this case, which is stating that is the less stance, or maximum it's going to be the equal. Sometimes it can be the equal, but majority time it's going to be the less. So what is over there? This is the true hypothesis you are accepting over here. Yes, it is lesser than that. Okay, I hope you understand these things. And this is the last thing. You can utilize the built-in data set as well. And this is all from my side. Now we need to go for the question answer sessions. And I would like to stop the screen share and go to the Fatima or dear Ma'am Ruxana. I think so we can go for the question answer sessions now for the 30 minutes or 25 minutes, whatever you wanted. Thank you very much from my side.
Zanik, you can take it forward now.
Sorry, ma'am. What did you say, ma'am?
उसको फिर जाके उसको इतरत, we are sorry, due to my internet issue, I cannot start the video.
Ji, ma'am, I can hear you.
Yeah, you can hear me?
Yes.
My internet is giving me trouble. I'm happy your internet in the next room is working.
No, my internet was went
And
well,
it was
I think so.
a very good session with lots
Thank-
of energy and gusto. And I
Thank you
must
very much.
remark that you are a very good, I think, teacher who explained very well. And I'm sure, look at the number of participants in your session. So
Yes.
we are very delighted. Zarik will now, ask the questions that are there.
Sure.
And we will, Zarik, will you please collate the questions? There are some 39, 40 questions or comments.
Okay, my throat is not working, but I will try my level best to give the appropriate and explicit answer to everyone. That's it. Can you,
I
Zarik,
can't
please?
hear you, Itrat. अगर थोड़ा सा
Okay.
ऊंचा बोलो.
Ji, ma'am. I said I'll try my level best to give the best and optimal answer to each question.
Yeah. We have another half an hour, so we have enough time for question and
No
answers,
problem,
but
no problem.
fantastic session.
Yes.
Ji Zarik?
Okay, ma'am. So I've been noting down the questions just as we open the chat, and we'll be starting off with the first one, which is from Batool, who is from SMBBU Larkana. She asks, as an MSN student working on nursing research, which types of visualizations are most useful for presenting survey data and research findings in a thesis or journal article?
My dear, the good name of the researcher I forgot, but my dear,
Batool
you can
Kohave.
Batul. Dear Batul, you can see according to the variable and the research questions. What is your research question? What is your hypothesis? If you are working on the quantitative aspect, I do recommend go for the simple univariate analysis. Let them know about the percentages of the important and significant variable. Go for the correlation, as I told you, for the R, for the quantitative, and for the chi-square testing must be for the qualitative. You have to go for that. Contingency table develop in your research, and then go for the multiple linear regression, at least the linear regression, simple or multiple linear regression with their appropriate diagnostic tools. Priorly, you need to test it out, the assumptions, and fit the specific model on that. If your response variable is like the proportion on the probability you are working, so then obviously the simple and multiple linear regression is not going to be working for that. You have to go with the logistic regression for that, and there are some other assumptions and constraints, but I do recommend at least you go for the multiple linear regression modeling in your research. Depend on the research question. That's it.
The next question is from Dr. Ehsan Farooq, who's joining us from Rifa University. He asks, R's coding environment lacks the drag and drop interface like in SAS. How can we make R-generated graphics accessible and easy to interpret accurately for non-technical hospital staff, including clinicians, nurses, and executives, without requiring R code knowledge?
Sir, you are, yes, SaaS is, it's quite expensive. So this is the first and foremost purpose to go for the R. You are right, quite right. So there are some constraint as well. Obviously, drag and drop is quite clear and efficient, I would like to say, into the SaaS. But SaaS is highly paid. Even though we are working in a very good environment at FCCU, still here we are not opting for the SaaS, and SaaS is quite expensive. So everybody cannot be assessed to the SaaS. Everybody can assess to the new and sophisticated version of the R, and it's having, and even though the Python as well. So there is no ethical issue to opting the Python and the R, and some constraint, you can say 10% constraints, so we can bear it if you are having such and such facilitations like R is giving you for the with the no ethical issue, with the free version, with the free sophistications. So I think such issues can be managed through that.
The next question is also from Dr. Ehsan Farooq, who follows up with the previous one, saying, R is open source, ensuring that every plotting function or aesthetic produces exactly the same output on any machine. Can another researcher run the exact same script on a different machine and generate the identical visual output?
Uh, yes. So even though the codes I have shown you, you can go it simple by the ggplots. Okay? With the through simple ggplots, you can go, but the more complicated, you see the code of run, you have to run it for that, and the visualization aspect will be suffer over there. The quality, you can say, the graph will be suffer, which I have been shown you is more sophisticated than that, and the presentation for the research purpose will be suffered, I think so. This is my observation. Maybe it can be much more things over there included in that, but my observation is that the quality will suffer if you will go for those things.
The next question is again from Batool, who's from SMBBU Larkana, who asks, for research data, how do we decide which visualization is the most appropriate for a particular type of variable or research question?
Yes, my dear, you can decide certainly. As I told you, if you have the quantitative variable, so there are other streams of the visualization, like you can draw, if you have the time series data and the quantitative data, you must be draw the trend lines for that. You must be go for the ARMA model for that. If you have the quantitative continuous variable for the research purpose, then go for the simple linear or multiple linear regression model for that. And the graphs I have shown you. If you have the response, it's always depend on the research question. What is the response on which you are working and how many significant variable are related to that? If the quantitative variable related to that, then you have to go for other visualization aspect. If the qualitative variable are related to that, then certainly you go for some other aspect. Like the quantitative, I can let you know the histogram can develop, the trend lines can be developed, the tree mapping can be developed, the pie chart, tree map can be for the both, for the qualitative and the quantitative. And for the qualitative aspect, you can go for the proportion like that. So variable bar graphs or the stack bar graph or the multiple bar graphs or the pie charts, as well as the tree mapping you can. And rigidly, if you have the qualitative data for, then you can go for mosaic plot. Like I can give you the example, if you have working on the Titanic data mein kya tha? You have it the gender, male, female, or more sophisticatedly, I can say you have three categories: children, male, female. How many die, how many don't? Alive and death, like that. Both are categorical. So mosaic plot is very much appropriate for that. Then you can go for the heat map. Heat map can be utilized. Let's you are working for the car data. Okay, you are working for car data, different brands of the car, and each brand is very important to you. Toyota, Mercedes, and like Suzuki, and blah blah blah. Different car types over here. But for the each car category, for the each car, you are having its own horsepower, its own cylinder, its own mileage, its own color specifications, like that. So every variable can be important for the categorical variable, and so many categories for that. So this sort of data, you can utilize the heat map. So it's entirely depend on the nature of the variables, which variables you have it in the hand, and certainly which graph are appropriate according to the nature of the variable. Priorly, you can decide certainly. Firstly, you have to know about the nature of the graph. That's it. Nature of the variable, sorry. Ji beta.
The next question is from Dr. Irfan Ahmed Abbasi, who is from DUET. He asks, what art package would you recommend for creating publication quality graphs and figures in R? Also, is it possible to use it for XRD and FTIR graphs?
Yes, sir. You can certainly call it these files over there. Yes, why not? But our package, I would like to recommend dplyr by default, because EDA is very good by the dplyr. tidyr, it's having the big window in that, utilizing even the ggplot for that. So tidyr, tidyverse, ggplot, dplyr, these are the very much famous packages in which you can do I think so, majority of your work. These are the very much famous and more sophisticated packages in which you have done so many things.
The next question is from Pervez Ali, who's from SMBB University in Larkana. He asks, what visualization techniques are the most effective for presenting results from randomized controlled trials or intervention studies?
Randomized controlled designs. If you're talking about the designs, my dear, so there are more sophisticated plots for that. Obviously, in that, there are different assumptions that they are all independent. The response variable, even though for having the different natures. So again, I would like to say, firstly, you need to decide the nature of the variable. And then randomize, if you are going for the design, complete block design and factorial design, so it's a surface plots. The response surface plot you have to develop for that, which let you know about the normality of the data. Usually we need to be tested out in that, and the response surface plots are very important.
The next question is from Sabah Abru, who is from SZABIST University in Larkana. She asks, under what conditions can p-values become unreliable due to violations of statistical assumptions?
My dear Sabah, firstly, being a statistician, I would like to say, first of all and foremost, we need to test the assumptions. If without assumption we are doing our work, then it's mean everything is misleading to you. Not just the p-value, not the good R scare value, not just the estimated value. Everything is going to be biased. So priorly, we need to test the assumption of a specific test or tool to apply in statistics. So I would like to say some people came from different domain. Obviously different, like bio say, for example, people came to us from English literature say came to us and they said इसमें डिजाइन लगा दें, मतलब यही जैसे क्वेश्चन वाज आस्क्ड बाय समबडी कि जी सिंपली लीनियर रिग्रेशन मॉडल और मल्टीपल लीनियर रिग्रेशन मॉडल और लॉजिस्टिक मॉडल लगाना है, तो देयर आर सम स्पेसिफिक डिस्क्रिमिनेट एनालिसिस करना है आपने, फैक्टर एनालिसिस लगाना है आपने. There are some specific conditions, my dear, for each conditions meant for assumptions. Okay? If the assumptions are fulfilling, then it will give you the best answer. And if it is utilizing, then there is a very minimal chance for misleading it up. And now, certainly you are right that I'm not saying that it's 100% the correct thing to just rely on p-value. Obviously, it's the merger of that. When you are utilizing the assumptions and simultaneously relying on the p-value and the other diagnostics, then the combination will let you know that you are into the right direction.
The next question is from Sumaira Mazhar Magsi, and she asks, can our visualization be easily integrated into Power BI or other web applications?
Yes, my dear. Power BI is very much sophisticated, I would like to say, but it's on the online spot or the presentation mode is very good. But for the research purpose, certainly you need to paste the pictures. So the picture quality, it's again depend. So whenever you are giving your presentation, your final thesis presentation, then I do recommend make the Power BI plots, make the Power BI presentations, make your Tableau presentations. It's very good and very sophisticated. But for the research publications, it's not to be that much recommended in my sense.
The next question is from Dr. Sara Mufti, who asks, for t-test, you work on unknown population, which is usually the case in social sciences. On the other hand, Z works on known population, and this is a citation from Gravache and Wallnau 2017. She's asking, can you please quote a reference for the sample size you have explained in your presentation?
Sure, my dear. Any book of statistics you can take it. Not the reference specifically you needed. Any statistical book you can pick, and you can see it into doubt that the n has to be less than 30. So T, and if n is greater than 30, so you go for the Jordan. So many, my dear. Any book I would like to recommend. Koi bhi book utha le, so it will give it to you. But one more thing. I said that to apply the t-test भी apply करने के लिए, what you needed over there, assumption is that जहां से आप sample ले रहे हैं, the population has to be normal करने का क्या मकसद है? Normal करने का मतलब है bell shaped meant for unbiased meant for it's having the equidistance from the edges as well as, and it has to be asymptotic, never touches to axis, going to be 0, 0, 0 probability over there, minus infinity to plus infinity, but still equidistance from the center, okay? Equally spread from the center. And when you're having the mu plus minus 3 sigma limits, you're having 99.73% area covered ho jata hai. ±3 में कवर हो जाता है, तो asymptotically you do not need to go for that. And one more thing, you said कि जी t test को, sorry, the question was again please. एक और बात आपने पूछी थी.
The next question we have is from Muhammad Ahmed Khan, who asks, as per theory and hypothesis, there is a positive relationship between the variable. How do you interpret if the correlation is possible, but t-value and regression coefficient is negative, although p-value is less than 0.05?
Okay, so there is the problem with the data, my dear. Maybe the bias data you have it in your hand, maybe the less number of observation you have it in the hand, maybe inappropriate variable you have it in the hand. So that is called to be the inferential point, कि कोई ऐसा point आपने निकाल दिया है या variable include नहीं किया जो कि inference कर रहा है, and that is go for the categorical data analysis. आप अपने categorical data analysis करें उस पूरे research पे, then it's giving you the most sophisticated. It will give you the saturated model. It will give you the certainly you have to go for the saturated model, full model. यानी कि अगर all possible 100 variables हो सकते हैं, सब 100 पे लगा दे, तो उसका deviance क्या होगा? Minimal आएगा. Obviously, जब पूरे पे काम करेंगे तो minimal आएगा. But it will mislead you sometime. Obviously, it's not appropriate. क्या करेगा? बहुत अच्छी R square की value, बहुत अच्छा diagnostics. But लेबर वर्क तो हमारी बहुत ज्यादा होगी ना, 100 हमने वेरिएबल्स ले लिए, सो यू नीड टू जॉट इट डाउन फॉर द सिग्निफिकेंस वेरिएबल. बट सर्टेनली इफ यू हैव दीज सीन्स कि आपकी पी वैल्यू आपको इंडिकेट कर रही है लेस और आपका कोरिलेशन आपको नेगेटिव दे रहा है, समटाइम ऑब्वियसली इट इज डिमांडेड दैट देयर इज अ नेगेटिव कोरिलेशन. डिमांड होता है लाइक द प्राइस एंड द डिमांड में, इकोनॉमिक्स में इफ यू टॉक अबाउट दैट, द प्राइस और डिमांड में नेगेटिवली कोरिलेशन है, और वो क्या होगा आपके पास? हाईली हाईली p value उसकी रिकमेंड करेगी. देयर इज अ स्ट्रॉन्ग नेगेटिव कोरिलेशन. बट इफ यू आर सेइंग कि मेरे पास सप्लाई और प्राइस का कोरिलेशन नेगेटिव आ रहा है, तो इट्स यूजलेस, इट्स सेंसलेस. इसका मतलब है सम इंपॉर्टेंट वेरिएबल जो कि इन्फ्रेंशियल हैं, you did not include it into the research. It can be the sample size can be smaller in your research, or the appropriate variable you did not utilize. That can be the three things.
So the next question is from Dr. Amar Ali Chuktai, who is a faculty member from Forman Christian College. And he asks, you mentioned that in case of unequal variances, t-test cannot be used. However, SPSS calculates the t-values in case the variances are unequal. SPSS uses Levene's test to determine if variances are equal or unequal. So it's
Yes.
sort of a comparison asking what is the advantage of using R over SPSS?
Yes, again, my dear, the same as that. SPSS is the paid version. That's it. It's more user friendly, I know. Okay, SAS is more sophisticated, I know. But R is free and giving you 99.9% things are more than that. But if you have it the such and such, you can say the facilitations by the university or by yourself, you can opt it. If there is no ethical issue, not the pirated version, you have it, then go ahead. I do recommend, because SPSS is obviously more user friendly for the social sciences people. And one more thing, if it's giving you, then there is some conditions prior to that, obviously misleading. If it's giving you that the t value it is calculating, it's a well-chi test, you can utilize for that as well. So many other things, but the basic assumption for going, the true assumption, being a statistician, I would like to recommend you, priorly you need to test if the variances are not same, then do not go for that. What the SPSS do for you, more, because I'm not utilizing it from the last 5-6 years, whenever I have switched it over there to the R and Python. So maybe the new version of the SPSS transform it for you. Transform your data priorly to that. I'm not sure, but you need to test it out, because this is the first and foremost condition that if the two sample t-test for the independent sample you need to be apply, the both variances has to be same. Otherwise, it's a misleading result for you.
So the next question is from Dr. Jam Muhammad Zafar, who asks, what is a correlation coefficient? Tell us about the strength and direction of the relationship between two variables.
Yes, sir. The correlation coefficient is basically ranging from -1 to +1, and it's a unit free number. It's a pure number. Means अगर मेरे पास 0.5 है, so I can say 0.5 is greater than 0.4. That's it. It's a pure number, ना? कोई unit नहीं है उसमें. So जितना जितना you are increasing towards 1, अगर आप 1 की तरफ जा रहे हैं, 0.9, 0.99, 0.98, 0.7, 0.5 से इंक्रीज होता चला जा रहा है, मॉडरेटली स्ट्रॉन्ग है रिलेशन 0.6 तक. 0.7 onward, it's going to be strong correlation, positively, strongly correlated, or the same is going for the negative. Kindly do not say that there is a weak correlation if you are getting -0.9. -0.9 is just saying the direction of the two variables. Like I have given the example of the demand and price. They are both highly correlated, but into the negative sense. So if you got the -0.9, it's meant they are strongly negatively related. Yeah, if you got the value lesser than like nearest to 0, 0.01, 0.02, 0.05, 0.02567, like that, or zero point 0.1, even 0.2. So it seems to be the weak correlation. There is more and more chance that the two variables are going to be independent in that sense. They're having no strength of association. Like, I can give you the example. We can check the relationship between the two nonsense variable. What the nonsense variable can be? The number of, you say, crimes in a society and the number of mosques in that society. So mosque का crime के साथ कोई relation नहीं है. So even though you can check the relationship between two nonsense variable, but क्या होगा? Result will suggest it to you 0.0001. Yeah, nothing like that. So it's going to be no correlation. The both are independent. They are depending on something else. That's it. So correlation can be on the two dependent variable, two independent variable, two one independent, one dependent, and any variable.
The next question we have is from Farzana Yusuf, who's from the University of Education, Lahore. She asks, sometimes only a space in code doesn't show the required results. So in order to avoid that, can we use generative AI tools to code?
Yes, I do recommend to the researchers, to the serious people, for yes, they can use the AI generative tools, but you have a prior knowledge of your work. For example, sometime we make the, let's say, once I was working on a paper and I said, okay, iska na hum banate hain histogram. Histogram was letting me know कि मेरा normal data नहीं है. And generative AI was giving me Chat GPT, for example. Gemini है, Chat GPT है. So Chat GPT is utilizing very much by the people nowadays, free version, and it's giving me क्या normality दे रहा था. Then I discussed. I just want to say, do not completely rely on that. At least you have some prior knowledge for that, the basic knowledge. Do not blindly depend on that. Please, prior knowledge hai, so do utilize it. Then you can debate, then you can discuss with that. Yes, certainly go for that.
This question is from Muhammad Zishan, who's joining us from Virtual University of Pakistan. He asks, how can we use R to compare multiple competing hypotheses by selecting appropriate statistical models, checking model assumptions, and validating the results through diagnostic tests and goodness of fit measures?
So certainly, sir, the different codes, you have to write it for that, obviously, because it's a coding language. And due to the free version, we need to learn the codes. It's yes, and through, like the SPSS is more user friendly, but here it's quite hectic to learn the codes, as we were discussing. That you can use the generative AI tools for that if you have not the good coding knowledge, but at least the statistical knowledge you have it, that the result has to be like this or that, not the nonsense results you have to take it over there. So the codes or the some consultation through the statisticians for the research purpose, I do recommend for you. go for that. Why not? You can certainly write the proper codes. Not in a one code you got it, obviously. Yes, in a one code you got the summary statistics and the so many things in the so many sophisticated codes over there. You can got it, but different codes and code streams you need to be write it for them to get the different objectives. To fulfill the different objective, you have to write the streams of the codes for that. And on a one click, you see the results.
The next question is from Dr. Asif Farooq, who's from RIFA again. And he asked, could the package export the visualization into regulatory friendly high resolution formats like specific PDF dimensions or RDF files for clinical study reports without losing text legibility?
Yes, sir. RMD files, you can make it over there. Obviously, why not? It's a high text file over there and import it and develop it automatically through the R. And if you have the word, even though you are getting the result into the R and you would like to see that one sophisticated PDF file has to be generated with a high resolution graphical representation. So RMD file, you can develop it automatically.
This is going to be the last question for today's session because a lot of them have already been covered, and some of the questions were related or about SPSS. And this is an announcement for the participants. We have a session scheduled for SPSS in data analysis on 6th of July. So all of those questions will be answered for that session. For this, the last question will be who's from Batool, which is from Batool Khawar from SMBBU MU in Larkana. She asked, what are the most common mistakes researchers make while visualizing data in R, and how can we avoid them?
Okay. The most common, because we took this as a course to the students, obviously we are advising the students in that the most common mistake is that it's a case sensitive. What the people do usually, they forgot to putting the inverted commas like that. For example, they are writing misspell it usually. Do not misspell the package. Do not, it's a case sensitive. Please be careful about the it's a lowercase, so write into the lowercase letters. If it's a cap lock, so write into the cap lock. One starting is the cap lock, rest is the lowercase. So please do careful about these things that you have to write the correct spelling into the correct style. So these are the common mistakes जहां पर stuck हो जाते हैं, आपका पैकेज ही नहीं डाउनलोड होता तो फिर आप stuck हो जाते हैं सारे का सारा. That's it. Thank you very much.